Namaskar, dear facilitators, passionate teachers, and future builders. While explaining the chapter Improvement in Food Resources, have you ever wondered whether our students truly connecting with the content despite our best efforts? Are they just memorizing facts, or are they realizing the deep link between science, survival, and sustainability? Today, let's not just deliver content, let's deliver experience. Let's plant seeds in minds and in hearts. Join me in an experiential journey where learning is not told, it is lived. Let's begin with a simple thought. A thought that millions of farmers live every season. Imagine yourself standing on your farm at sunrise, soil under your feet, seeds in your hand, and asking yourself, what should I grow this season? The answer is not simple. Crops do not grow just because we want them to. They grow because nature allows them to. Today, let's not just teach students about crops. Let's make them feel the connection between life and seasons. Let's experience it together. Friends, for a deeper understanding, you may refer to the NCERT Class 9 Science textbook, which provides detailed insights on each of these concepts. Dear facilitators, according to CBSE Experiential Learning Guidelines, before introducing any concepts, we must activate prior knowledge using inquiry-based techniques. You may begin by asking students curiosity-generating questions like, why do we not see apple trees in Kerala? Why does rice grow so well in Assam and Bengal? Why do farmers change crops with seasons? How do sunlight and rain affect plant growth? Dear facilitator, you may give learners 2-3 minutes to think, pair, share. Observe their responses without correcting immediately. Possible student responses might include: rice needs water, some crops need cold, some plants die if it rains too much. Having gathered satisfactory responses, guide the students towards an experiential learning instead of rushing into definitions. Let's move to a discovery-based simulation. You may give learners following instructions for the activity. Divide your classroom in 4 groups: hot and wet zone, cool and dry zone, dry and arid zone, flooded land zone. Make them write crop cards by writing on them paddy, wheat, maize, cotton, gram, watermelon, etc. Friends, let's create an imaginative moment for the students. Tell them, close your eyes. Imagine you are a seed. You must move to the climate where you will survive best. Think carefully before you move. After this wonderful imagination exercise, now we move into the stage of conceptualization. Facilitators, now you may guide the students to scientific understanding. You may explain like, students, just like you imagined yourself as a seed looking for the perfect home, crops in real life also depend on nature's conditions. Every crop needs a specific temperature, rainfall, and sunlight to grow well. For example, paddy needs hot, wet conditions. Wheat needs cool, dry conditions. In India, farmers classify crops into Kharif, Rabi, and Zaids, seasons based on weather patterns. Also, the amount of daylight, called photoperiod, decides when crops flower and produce food. Photoperiod refers to the duration of sunlight a plant receives in a day. It plays an important role in the growth and flowering of crops, which directly affects their yield. Some crops require longer daylight hours to flower, while others thrive in shorter light periods. In addition to sunlight, the soil type also influences how a crop grows. For example, loamy soil, which holds both water and nutrients well, is ideal for most cereals. On the other hand, clay soil is better suited for water-loving crops like paddy due to its ability to retain moisture. Furthermore, different crops are adapted to different climatic conditions. Some can tolerate drought, others survive in flooded conditions, and some are sensitive to temperature fluctuations. That's why selecting the right crop for the local environment is very important. When farmers match the crop's needs with the natural conditions such as sunlight, soil, and water, they ensure better growth, higher yield, and sustainable farming. Thus, understanding climate is not optional, it is essential for farming and food security. Dear facilitators, now let's assess and apply what students have learned in the form of application-based tasks like: Dear students, imagine rainfall in your village decreases suddenly. What crops would you now suggest farmers to plant instead of rice? Think and design a smart farming plan. I'm sure that students will come with wonderful and innovative ideas. This task will build up critical thinking and problem solving skills. Now, further let us know what learning outcome we achieved so far. Now, student will analyze how temperature affects crop growth and apply this knowledge to optimize production. Beyond knowledge, it's the values we nurture that shape our future citizens. Values inculcated are environmental responsibility, critical thinking, scientific observation, and teamwork. Friends, now look at the assessment rubrics. Clear assessment criteria help students understand the goals and celebrate their progress. So, rubrics should be based on learners' observational skills, reasoning ability, application thinking. Dear facilitators, now students have experienced how climate controls crop growth. Let's guide them towards a deeper realization. Nature alone is not enough. Human, through innovations, have created seeds that survive floods, droughts, pests, and feel the world. Let's now make students experience the power of science to improve crops. Friends, to activate curiosity, you may start with PK testing through inquiry-based questions. Ask students, do you think today's wheat is the same wheat that existed 500 years ago? How did we get rice varieties that can grow in salty soil? Can farmers create new seeds themselves? Let them think and discuss in pairs. Friends, surely you will list out some possible student responses based on their observation from real life experiences. Having gathered satisfactory responses, now you may guide the students towards experiential activity, that is Super Seed Challenge. Friends, you may give them activity instructions along with briefing and definition of some important terms that are new for students, as this is very important for smooth conduction of activity. You can give or make them write disaster cards randomly showing or written some disasters like drought, flood, salinity, pest attack, low soil fertility. Give trait cards showing traits like high yield, drought resistance, pest resistance, salt tolerance, short duration, high nutritional quality. Friends, now you may ask students, you are now seed scientists. Your mission is to design a new super seed that survives disasters and feed the world. Think critically, choose traits wisely. Reflective observation. After task completion, ask students, why did you choose these traits? How will your seed survive in floods or droughts? Which was the most important trait in your design? Now, dear facilitators, connect their creativity with scientific explanation. Farmers and scientists improve seeds using some major techniques called selection, hybridization, and genetic modification. You may explain these concepts by using certain facts and examples. By further explaining them, major developments in the field of agriculture like high-yielding variety seeds, seeds with improved quality, seeds with biotic resistance, seeds with abiotic resistance, seeds with wider adaptability, seeds with desirable agronomic traits. Now, dear facilitators, assess and apply the concept, challenge students creatively. Dear students, now imagine you work at an agricultural innovation company. Design an advertisement for your super seed. Your poster must include name of the seed, traits of the seed, how it helps farmers, why farmers should trust your seed. Friends, with the poster, we are integrating art and science, nurturing multidisciplinary learning among learners. Let us know what learning outcome we achieved so far. Students will identify methods of seed breeding to improve crop quality and apply these techniques to enhance agricultural production. Friends, values to be inculcated among learners are innovation and creativity, responsibility towards food security, scientific curiosity. For evaluation, use assessment rubrics, communication skills, innovation, scientific linkage. Dear facilitators, so far our students have discovered how to grow crops and improve seeds. But food production does not stop there. Another important pillar of food security is animal husbandry, and poultry plays a vital role. Let us now guide students to understand poultry farming scientifically, analyzing breed traits carefully to maximize egg and meat production. Let us not just teach them facts, let us make them think, decide, and solve real life food problems as future agricultural leaders. Dear friends, let's start with pouring up curiosity with prior knowledge testing. Ask students, why do some hens lay 300 eggs per year while others lay only 50? Why do broilers reach market size so quickly? You can ask learners to discuss these points quickly in pairs. Friends, you may now collect possible student responses like different breeds have different strengths. Some grow faster, some survive better. Food care and environment matter. Having got satisfactory responses, now you may guide students like, dear learners, now get ready for concrete experience by adding another energy-filled activity. You may give instructions like, divide students into teams, give each team a farmer case study to diagnose. Example cases like chickens dying in cold, low egg production, high disease losses. Then provide learners breed trait information sheet as shown in the visual. Broiler, fast growth, low disease resistance. Layer, high egg yield, moderate adaptability. Indigenous, hardy, slow growth. Distribute diagnosis worksheets like the one we made. Facilitator may boost the learners and say, your mission is to solve real farm problems using scientific thinking. Diagnose what went wrong, choose the right breed, and suggest full management solutions. Remember, every advice must be based on science, not guesses. After teams fill their worksheets, here comes the reflection stage. Friends, you may ask teams, how did you identify the causes of the farmer's problem? Why is breed selection so critical in poultry farming? How can wrong choices affect the farmer's income and survival? Collect responses of the students and further start with concept building. Let's begin with scientific explanation now. Facilitators may explain clearly. Students, poultry breeds are selected based on specific desirable traits. Management practices must match breed needs. Good feed, proper vaccination, shelter adapted to weather. Friends, we may enhance their knowledge by providing them self-explanatory visuals. Let's apply and assess now. Facilitators may say, now, dear students, prepare a quick poultry management plan. Suggest right breed, shelter design, feeding strategy, vaccination plan. Present your plan to the class scientifically. Each team present their farm plans. Class listens and then may share peer feedback. This group learning surely develops in learners' social skills. Friends, by the end of this session, student will be able to analyze desirable traits in poultry to enhance egg and meat production. Friends, values to be inculcated among learners are scientific temper, entrepreneurship, ethical responsibility. Assessment rubrics are diagnostic reasoning, application thinking, communication. Dear facilitators, after experiencing the journey of improving crops and livestock, now let's prepare students to defend what we have grown. Because food production does not end with planting, it continues with protection. Let's experience how we safeguard crops naturally and sustainably. Let's move towards PK testing first. Facilitator may ask students, why do farmers sometimes lose crops even if they take good care? What invisible enemies attack fields? Can you think of natural ways to protect crops without harming the environment? Learners may do quick discussion in pairs. Facilitators may collect expected student responses, like shown on the screen. Having got satisfactory responses, now you may guide students. Now, let's experience how real crop protection science works. For concept building or interest building, show students clear visuals of affected crops that can be printed or projected. Share with your learners information on weed infestation that include insect attack, fungal diseases. In small teams, students must diagnose the problem. Suggest protection methods like mechanical or cultural control, chemical control, biological control. Now here comes the reflection stage. After visuals, ask them related questions. Facilitator may ask learner, how did you identify whether the damage was due to a pest, weed or fungus? Why is it important to use eco-friendly solutions instead of heavy chemicals? How can farmers balance productivity with sustainability? Facilitator may now build full concept naturally by sharing knowledge on the types of stresses on crops, crop protection methods and various controls. Facilitator must share with the learners the harm caused by overuse of chemicals to soil, water and human health. Students must be acquainted with the term integrated pest management, a scientific method that balances cultural, biological and chemical controls. Now, let's extend the topic of organic farming. Facilitator may add important ways by which learners could practice organic farming at home to apply classroom knowledge effectively. We could also create small vegetable garden in our school, sending a strong message of sustainability. Reflection on learning methods. Friends, our students are now equipped with inquiry-based learning through the curiosity-based questions and prior knowledge testing. Experiential learning by concrete experience and hands-on simulation activity. Reflection by facilitating critical thinking and reflection after the activity. Conceptualization by connecting the experience to scientific concepts. Application by challenging students to apply knowledge to real-world problems. These methods help in building cognitive skills, interpersonal skills, and intrapersonal skills in learners. We walk through seeds, through soil, through seasons, and into the hearts of farmers and the fields of our future. We did not just talk about food production, we lived it through experience, reflection, and innovation. In your hands, dear teachers, lies the power to sow not just crops but scientific minds and responsible citizens. Let us commit that in every lesson we will make students not only learn science but live science, think science, and protect nature. Because when we teach them to respect a seed, we teach them to respect life itself. Thank you for being the gardeners of tomorrow's earth. Let's sow, let's nurture, let's sustain. Thank you.